All right, class. So I hope you took your time and you carefully went through the worksheet and did your best in trying to come up with the values on these trig equations. This is an important worksheet and really leads us into the second worksheet that's coming, and that one you guys will turn in for a grade. So I hope you'll pay attention to the details here, and let's see how you did. All right, so trig equations. So let's start off. I've got the patterns up there, right? And you can see those patterns. And that's important that we understand the pattern as we try to figure out the value of these trig functions. All right, first off, we have to isolate the variable, just like you would in any equation. And we're after an angle. So we're after an angle. And we have to take note that we're only looking for values from 0 to 360. All right, so only values 0 to 360, we are looking for the angle. So I want to move that 3. Just like always, things added to the variable, you're going to move by adding their opposite. So that's going to become a 2. And then we're going to divide both sides by the 5. And so right now we have sine x equals 2/5. So then the measure of angle x is going to be sine to the -1, right? -1 button gives you your angle of 2/5. Now, all of this is in respect to a restricted domain. So because of, remember when you get inverses, to have an inverse, you have to pass the horizontal line test. And as you can see, a trig function, here's a sign up here, fails the horizontal line test. You know, you hit more than one point with a given horizontal line, with any horizontal line. And therefore, then we have to restrict the domain. And so the sine has a restricted domain that goes from -90 to 90. So whenever you're using the inverse button to figure out an angle, your calculator will always give you values between -90 and +90. Notice how this now passes the horizontal line test. Okay, so we have to keep this in mind, that our calculator is going to give us values between -90 and +90, and then therefore we have to find the other values within the prescribed domain. Okay, so that's what we're after and that's where we're heading. So let's see how we get there. So let me punch this into my calculator. Sine to the -1 of 2/5, and I get measure of angle x is approximately 23.6 degrees. Okay, so now there are two ways to look at getting any additional angles with this 23.6 degree angle. So let me go a little higher here now, and I'm going to work off of the two models. So we've got a radial model and we have a linear model there. And so there's two different ways to go about this. Now, I already know one answer is 23.6. That's within my domain of 0 to 360. And so that's one solution. Now I have to find the other angle. So I'm going to go first off to this horizontal type view. And so 23.6 degrees, I don't know. I'm just going to stick a, let's suppose that that is somewhere about there, right? Because again, that value right there would have been 2/5, right? And so right in here is your 23.6 degrees. Now, is it pretty clear that your other value is going to be right there? So now you have to figure out what is the value there. Well, again, come down here and notice in here, between this mark, these two marks right here, is your 23.6 degrees. So therefore, then our angles are going to be 180 minus 23.6, and that is a value of 156.4 degrees. Okay, so that's that methodology of getting there. Let me show you the radial view. So we're here and we're at 23.6 right in there. Notice our reference triangle. Notice we're doing the sign, right? Why are we doing the sign? Because the trig function was the sign. And notice the sign is positive in quad 1. Now, why is the sign positive in quad 1? Because the sine of the angle is the opposite, and the opposite is positive in quad 1, over the hypotenuse, and the hypotenuse is always positive. So opposite positive divided by hypotenuse positive gives you a positive sign in quad 1. Now, it's imperative that you know the other quadrant where the sign is positive, and the answer is quad 2. And so now I take this same reference triangle, right? This is why we learn reference triangles, 23.6. Again, notice how the opposite is positive and the hypotenuse is positive. So therefore, then you have to figure out what this angle is. And that angle is, again, 180 minus the 23.6 degrees. And there are your two angles. And that's why the two solutions are 23.6 and 156.4. All right, there's the first one. Number 2. All right, let me get my pattern out of the way here, and we'll get rolling here with number 2. All right, move this down. Whoops. Good enough for now. Okay, so in this, again, we're going to isolate the variable. So I got to move that 7. So I'm going to add a negative 7 to both sides. It's going to make that a negative 2. I'm going to divide both sides by negative 3. And so then the measure of angle A is going to approximate cosine to the negative 1 of 2/3. Cosine to the negative 1 of 2/3. All right, so let's punch that in. Cosine to the negative 1, and I get 48.2 degrees. So the measure of angle A is approximately 48.2 degrees. All right, now again, I need to take note of what they want us to give the values over, and that's from 0 to 360. Notice the restricted domain on the cosine is a little bit different, because the cosine starts at a max at 0 and ends at a min at 180. The restricted domain of the cosine, you'll always get values. Punch in anything you want in your calculator between negative 1 and 1, and you're going to get values between 0 and 180. This is all that your calculator will give you for the cosine, because that is the restricted domain for the cosine. Okay, so what we just found is a 48.2 degree angle. So in this scenario, we are 45 is going to be about there. So we're just going to be a tad past 45, right? And so we were right here, and this was our 2/3, right? So that's the value we found, 48.2. And now we have to find the other value. Well, again, we're coming across here, and there is our 2/3. Okay, so just had a brief interruption there, but no problem, and that was great. All right, so let's get back to where we were. So you got to be careful on this one. So looking at the radial view, so in between that mark and here is our 48.2 degrees. And so you have to be careful, and so we have to understand on the other end where we are. So we are 48.2 added to this 270. So this should be 270 plus 48.2. Let me punch that again. 270 plus 48.2. 320. Something is off. Let me look at this one more time. Ah, okay. So you got to be careful. This view is the trickier view. All right. So let me see if I can help this to make sense. No, I think we are it's okay. Watch. Let me use some color here. From here to here is the 48.2. Do you follow? So from here to here is the 48.2. So this value is going to be, let me go back to green here, 360 minus 48.2. All right, now we're good. 360 minus 48.2, and that is 311.8 degrees. Now, let me show that to you radially. All right, so we are at 48.2, and this time we are doing a cosine. So again, you have to pay attention to your trig function. And we have a positive cosine. Why? Because the adjacent in quad 1 is positive, and the hypotenuse is always positive. So we are in quad 1. Well, where else is the adjacent positive? And that is quad 4. So now our reference triangle is here. And do you see how that 48.2 is there? So do you see how this angle is going to be all the way to the 360 and then back up the 48.2, and therefore 311.8. All right, that's why you want to do that one. Let me get rid of my shade. We'll do number 3. And I don't think I'm going to need that. Let's extend my page. All right, number 3. All right, so again, this one we're just adding like terms, so don't let that scare you. 8 of them minus 1 of them is 7 of them. So we have 7 sine x equals -4. Divide both sides by 7. And so the measure of angle x is going to approximate sine to the -1 of -4/7. All right, so -4/7. Make sure it's negative. Inverse sine. And now you got to be careful here because the measure of angle x is approximately -34.849. So that's still -34.8 degrees. However, look at our domain, 0 to 360. So we're involved with 0 to 360 degrees here, and therefore we have to come up with the value, the coterminal angle, that is the same as a -34.8. You might say, well, why did we end up with -34.8? Again, because of the restricted domain on the inverse sine, right? So notice that -4/7 was a value. So we're about in, I don't know, maybe about there. So we're about here and come across, and that's where that -4/7 is, right? And actually I went probably a little bit too far. No, that's good, right? -34.8. So in here is your -34.8, right? Approximately. Okay. So now we got to figure out that value. So there's one of our answers right there. Okay. So be careful now that we understand where the 34.8 is. So between that point and that point is 34.8. So between that point and that point is 34.8. So this is going to be 180 plus 34.8. Punch that in and you get 214.8, and that's why one of the values was 214.8. How about the other value? Okay, now we got to keep going, right? And now we're over here. Now again, you got to be careful. Between here and here is the 34.8. So this value is going to be the 360 backed up minus 34.8. And 360 minus 34.8 is 325.2. And those are your two solutions, and that's why. So let me show you the radial view. So a -34.8 is in here, right? -34.8. And notice the positive is simply 360 minus that 34.8. Should have done that one in black because that is the 325.2 degree angle, right? Okay, so how do you get the second one when you're doing the radial view? Well, again, understand that the sine is the opposite, which is negative, over the hypotenuse, which is positive, and the sine is negative in quad 4. Where else is the sine negative in quad 3? So again, reference angle is going to be this 34.8, because again, notice that the opposite is negative and the hypotenuse is positive, and therefore then this other angle is going to be 180 plus the 34.8, and that gives us 214.8. All right, those are those two. Let's continue on. Oops, all right. Okay, number 4. So number 4, and dealing with the cosine. So we're going to add a -8 to both sides. That's going to give us a 0. We're going to divide 0 by 5, and that's again going to give us 0. So remember now, the measure of angle B will approximately equal cosine to the -1 of 0. Punch that in your calculator. You should know the value anyhow. And the answer is measure of angle B equals 90 degrees, and that's an exact. So when is the cosine 0? When the angle is 90 degrees. And you can see that we were right there, right? 90 degrees. So radial view, where else are we 0? Right there, 270 degrees, right? Horizontal view, excuse me. Now, these, when it's like this, these are really tricky to do with the radial view, because the 90 degrees is right here. And what happens is, I got to do it this way. Watch the reference triangle. Remember, cosine is adjacent. Okay, so you got that side's adjacent. See how the adjacent's getting smaller and smaller until finally, when you're right there, the adjacent equals 0 over that hypotenuse. And therefore you get a 0 and it's at 90 degrees. And that happens again. Look at your reference triangle there. Notice the adjacent is that size, and now the adjacent is smaller until finally at 270 the adjacent equals 0. And again, when you divide that by the hypotenuse, you get a 0 or 270. All right, so, but again, this view is by far the easiest way to get the two answers for number 4. But I like to show you both views because some problems it's easier doing the lateral view or horizontal view, sometimes radial, it depends. All right, number 5. Still going from 0 to 360. Here, let me use my shade so I can get that other problem out of the way. All right, so dealing again with the cosine, got to isolate the variable. Let's add a -8 to both sides. That's a -2. Let's divide both sides by -5. And so the measure of angle theta is going to be cosine to the -1 of 2/5. So 2/5 cosine to the -1. And I got 66.4 degrees. 66.4 degrees. Okay, so that's one solution because we are within our domain. 66.4, somewhere about in here, right? And this value right in here is the 66.4 degrees, right? Right here, and again, just for clarity, right? There was your 2/5 value, right? That produced the angle of 66.4 degrees. Where's our second angle? Going over to here. Now again, be careful. In here is the 66.4. So therefore take the 360 and subtract from it the 66.4. And what is that? 293.6? 293.6 degrees. Let me show that to you with the radial view. 66.4. Notice the adjacent is positive. The hypotenuse is positive. The cosine is positive in quad 1. And that's our 66.4 answer. But again, where else is the cosine positive. Well, the adjacent is positive in quad 4. The hypotenuse is positive in quad 4. So how do you get that angle? You go all the way to 360 and back up the 66.4 for the reference angle, and that's the 293.6. Okay? Both ways of looking at that. All right, 5 down, 1 to go. Last problem. All right, so this one a little bit interesting. We've got a quadratic, and oh, it's quadratic. You should be thinking 2 solutions. Let's move the 9, divide both sides by 9. Let's take the square root of both sides. And don't forget the what? Plus minus. So I'm just going to be clear here, right? That's the left. Right, that's the right. So I gave you an easy one. 4/9, square root of 4 is 2. Square root of 9 is 3, equals sine x. So we have 2 problems here. First off, we need to do the measure of angle x will be sine to the negative 1. I swap sides left and right. Sine to the negative 1, and I'm going to do the positive one first. And then second, I'll have to do, let's just use the eraser. Then second, measure of angle x will equal sine to the negative 1 of the negative 2/3. Now, if you forget the plus minus, you're only going to have half the values. And so you got to be careful here. All right, let's do the left one first. So I'm going to punch that in 2/3, inverse sine button, and I get 41.8 degrees. So the measure of angle x approximates 41.8 degrees. All right, 41.8 is one of my solutions. Again, let's go back to the horizontal view. 41.8 is approximately there. In this gap is the 41.8. And again, this was the, goes over to the 2/3, right? And therefore then our second value is going to be there. Now again, be careful. You have to be able to see that from there to there is the 41.8. So from there to there in this gap is the 41.8. So this second value is going to be the 180 backed up 41.8. So what is that? 138.2? And there's our second value. All right, we've taken care of the first one. Now we need to come back in and deal with the second one. So now when you punch in 2/3 and do negative, and then of course sine the negative 1, you get this angle x is approximately negative 41.8 degrees. Now again, notice we are not within our prescribed domain. So you have to understand, go back to the drawing, right here is the gap of the negative 41.8. It's between these two values right here, right? It's in this gap right in here. So again, you go down to here, and there is that negative 2/3. So now let's come across, and we're going to be right there. So this gap here is 41.8. And therefore the angle is 41.8 plus the 180, right? This 180 plus the gap of 41.8. And what is that? 221.8 is our third solution. And notice we're going to have a fourth right there. Now again, you have to be able to understand that right in this gap, right in here, is the 41.8. So I have to go to the 360 and back up and subtract out that 41.8 gap to get to that point right there, right? And so what is that? 118.2, 318.2 is the other value. And there you have it. So trigonometric equations. You've got to know your stuff. Oh, I didn't do the radial view. Let me go ahead and do the radial view. Because some of you, for some of you, the radial view is easiest. Okay, so 41.8 is right in here. 41.8. Sign is positive. Where else is the sign positive? In quad 2. So again, the 41.8 is there. So how do you get this angle? 180 minus 41.8, right? And that's what we did. 180 minus 41.8. Okay, where was the negative 2/3? Right here, right? This is the negative 41.8. All right, so I'll do the black one first on this model. So how do you get to that? Go all the way to 360 and subtract out the 41.8. Notice here the cosine is sine, excuse me, I'm doing the sine. Sine is, let me erase that, it's ugly. Got rid of too much stuff, but that's okay. So sine is negative in quad 4. The sine is also negative in quad 3. Same reference, 41.8. And how do you get there? We go 180 plus an additional reference angle of 41.8. There's your 221.8. All right, there you have it. And I hope you're understanding. Now, worksheet 11B is going to be a little bit more complex. So the complexity increases a bit. You might have upwards of 8 values for any given problem. And not only will we'll now increase the domain, and we might say, okay, give it to me with an unlimited domain. Instead of 0 to 360, give me all possible values. So you got to take that into account. So be careful going through and doing worksheet 11B. All right, there you have it.